Good morning, student. Let's start today's class. Okay. Today we are going to study about solar module. Okay. In previous classes, we have already shown that the what type of solar or type of solar cells. Okay. The fabrication or the manufacturing of the or process of manufacturing of the solar cell. Today we will see how that solar cell is used in commercial purpose, okay, or in power generation factory, okay. So solar module, okay, solar module you know monocrystalline solar cell have open circuit voltage of 0.6 volt and maximum closed current of 3 ampere for an area of 100 centimeter square, okay. 100 centimeter square of a solar cell, monochromatic solar cell provide the open circuit voltage 0.6 volt and the maximum closed circuit current 3 ampere, okay. This amount of voltage is not sufficient for most purpose, okay. This is very less, 3 ampere and 0.6 volt is very less for any purpose of work, okay. So we want high amount of voltage and high amount of current from the solar cell, okay. Then in order to achieve the required voltage or required high amount of voltage, solar cells are connected with each other in series, because solar cell is a or you refer solar cell as a battery, okay. So when we need high voltage, we add the battery, okay, in series, okay. but when but when we need high current, then the solar cell are connected in parallel, okay. Remember, because of in series the voltage is added and in parallel the current is added, so that for higher voltage we add solar cell in series, and for higher current, okay, the solar cell is added in parallel, okay. Remember this, okay. Such a unit of a solar cell combined together, okay, so is known as a module, okay. Such module are the basic building block of a solar generator, okay. Module, what do you mean by module, okay? This solar module, what do you mean by solar module, okay? Module is the combination of solar cells, okay, or the unit of solar cell combined together, okay. It's called module, okay, or solar module, okay. And that solar module is also the unit block of any generator plants, okay. Now let's see series connection of solar cell, okay. First we know that in series connection, or why do why do we do series connection? Because we need high voltage, or when we need high voltage we connect the solar cell in series, okay. Now let briefly discuss about series connection of solar cell, okay. Series of connection of solar cell are achieved by connecting the positive at the front of one cell, while negative at the back of the second cell. That means here you see there is 3 solar cell, okay, and this is positive terminal and this is negative terminal, okay. Here the positive terminal is connected to the negative or the back of the front of the, this positive terminal is connected to the front of the cell, and from the back it is connected to the front of the another cell. Okay, and here from the back it connected to the front of the another cell. Okay, then the voltage of solar cells added together with their when they are connected in series. Okay, the voltage will added. Okay, if it produce 2 volt, it produce 3 volt, it produce 5 volt, then they are all added. Okay, 235 235 and plus 5, the total 10 volt will be produced from this series connection. Okay, if we connect two solar cell with different current in series, okay, then we observe that the current in series circuit is the current of weakest solar cell. That means here you see these are three solar cell, okay, and connected in series. Okay, but the rating or the maximum current of individual solar cell is different. Okay, here the maximum current is 2 ampere, here the maximum current is 1 ampere, here the maximum current is 2 ampere. So here what happened, the circuit or the combination circuit or the series circuit current is here the series circuit current is the weakest. Okay, the current is of weakest weakest uh, solar cell. Okay, here you see the weakest solar cell, okay, produce 1 ampere. This is the weakest solar cell since it produce less amount of current. Okay, so the our series circuit, okay, the series circuit, the current flows in this series circuit is 1 ampere. Okay, from the circuit, the which from the circuit, uh, the weakest solar cell produced how that much or how much amount of current, that current is considered as a or a flow in the circuit of series connection. Okay, that is the disadvantages. Okay, so always connect the series or always connect the solar cell of same current rating, okay, in series. Okay, then this effect occurs when a solar cell is partially or completely covered due to the shadow of tree or by fallen leaf. Okay, and this is here you see this solar cell is weak or weak, so current is less. Okay, if this solar cell, let's say this solar cell is partially or fully covered by mud, okay, or dust, or leaf, fallen leaf, or shadow, okay, so that it produce low current. uh, um, you let the three are producing same current. First of all, let the three solar cell producing 2 ampere, 2 ampere, 2 ampere, but the middle solar cell is covered with leaf or placed in a shadow, okay, or covered with dust or mud. Okay, so it produce, obviously it produce less amount of energy. Okay, the current is also less. Okay, so the circuit, okay, so the circuit or series circuit, the current flows is 1 ampere. Okay, or or the less ampere. Okay, so this effect also produce as like the shadow or tree or covered by shadow or tree or fallen leaf. Okay, the power reduced and could even fall in zero. Okay, and the power inside the solar cell could be zero. Okay, in this place if that is covered with fully covered with fallen leaf, then the power could be zero. Okay, the same effect occurs if there is a break in module. Okay, the same effect is also occurred if there is an defect or break, okay, of a solar cell. Okay, under the load condition, okay, the irradiation cells provide current in the reverse direction, okay, direction, because the shaded solar cell work like a resistance. Okay, you see, when we connect when we connect the load, okay, here, okay, when you connect the load here, then the solar irradiated means uh, the solar cell on which the sun ray fall. Okay, that irradiated cells provide current in the reverse direction. Okay, reverse direction means in the opposite direction of natural current flow. Okay, because of the shaded solar cell, because the shaded solar cell, or which solar cell present in a shade, okay, works as a resistor. Okay, works as a resistor, and it works like a load. Okay, that means if this solar cell is present in shade area, that solar cell work like a load. How let's see. If this solar cell is present in the shade area, then it produce low amount of current. Okay, and it act like a resistor, okay, or load. Okay, so this current, or this solar cell produce how much of energy or current that feed to the that load. Okay, and due to that feeding, okay, here the temperature is produces or increasing gradually. Okay, and due to the temperature increases, okay, so it it destroy the solar cell, or the temperature destroy the solar cell. This phenomena is called hotspot. Okay, it can overcome by using same current rating solar cell only in series. Okay, that hotspot rating can be overcome by using uh, same current rating solar cell. Okay, then a bypass diode is attached across a desired number of cells. This number depends on the IV curve on the backward direction. Okay, here you see bypass diode is used. Okay, here bypass diode is used. Okay, and this diode is used for safe, or for not reverse current goes through the solar cell. That means this diode prevent that when in dark the current, okay, or the voltage not going inside the solar cell and get damaged. Okay, that damaged prevent by this diode. Okay, because diode only allow current in one direction. Okay, so it only allow the current from solar cell to source, okay, or reservoir. Okay, but it didn't allow current from reservoir to solar cell. Okay, that bypass diode is uh, protect the solar cell. Okay, now see, in parallel collection of solar cell. Okay, this is the parallel collection. Parallel collection of solar cell are achieved by connecting all positive and negative poles together. Okay, all positive poles of solar cell connected together, and all negative poles of the solar cell connected together. Okay, that connection is called parallel connection. Okay, the current through individual cell is added together. Here, the in parallel connection, the current is added, or here if this is 1 ampere, this is 2 ampere, this is 3 ampere, then total current is total parallel current is 1 plus 2 plus 3, that is 6 ampere. Okay, now let us see the module connection. You know, this is called module. Okay, or in series also this is called one module. Okay, unit of solar cell is called one module. Okay, then uh, only one module is provide only one module can provide that much of amount or current or voltage which we need. That is not correct. Okay, so when we need higher voltage or higher current, we use uh, module in series or parallel. Okay, modules in series or parallel only, not only cells. We uh, create unit of cells and called module, and that module connected in parallel or series. Okay, now let us see module connection. In practice, a module has all solar cell in series. Okay, and the module are connected in parallel. Okay, you know, in practice or in practical, in manufacture or in commercial industry, the modules are connected in series. Okay, no, sorry, the solar cells are connected in series. Okay, and the modules is connected in parallel. That means here, see, this is one module, this is one module, this is one module. Okay, so here inside that module, okay, the solar cells, okay, the solar cell is connected in series. Okay, and the module is connected in parallel. You know, this is the parallel connection. Okay, this happened in commercial or in practice manner. Okay, a safety diode is also used in parallel connection to flow flow of current into the solar cell during dark period. Okay, this safety diode is also used. Okay, then if a module is in parallel connection does not provide any energy because of said, it acts like a load resistor, and the rest of the module then feed this module and increase its temperature. To prevent this situation, one connect another diode in the series with each module. Okay, to achieve higher power, the module need to be connected in series and in parallel. Okay. Additionally, bypass diode or series diode are used. Okay. Now let us see. 1 minute. Now see one technique. Okay. One technique is used only one series diode per module. Okay. This is one technique of connection of modules. Okay. Here all modules are connected with each other. Okay, it is not necessary that all the modules deliver the same current. Okay, the main disadvantage of such a construction is a confusing overview. Okay, making it difficult to find an error. Okay, here you see this is a bypass diode is connected, and one series diode is connected. Okay, this is one technique, and this is also one technique. Here difference is that bypass diode is there, but individual series diode are there. Okay, for each module. Okay, this is the difference, and this is the advantages of this connection technique. Okay, here a module is made by interconnecting in series. Okay, and the joining of the row of such module in parallel. Okay, first the module is connected in series, and that row one row is connected in parallel. Okay, to find an error, each individual phase is disconnected, and voltage and current measured across them. This is the easiest method to find an error. Okay, here to find an error, we disconnect this row. Okay, and we connect or check the current and voltage rating. Okay, and also we disconnect this and disconnect this is the easiest method. But here what do you what do you uh, what here that it is difficult to find the error because the confusing. Here one diode is there, here no diode is there. Okay, there is a one diode for one uh, uh, one uh, one row. Okay, so there is very difficult or confusing configuration. So this is the uh, disadvantages of this module. Okay, thank you.